morning, algebra. This lessons continues our talk about percent change and the idea of interest, which as you grow to adult age, interest is a very big deal when talking about pretty much anything financial. And learn about what compounding interest means and like how credit cards are using interest and all that kind of stuff. So, sorry for the long video, but there will be an exit slip related to it. And hopefully the exit slip will be fairly short. I do not have practice problems today, so your video is really your best opportunity to learn. So let's just get started. Riley was given a savings account with a $500 balance. Each year the account earns 2% interest. If she makes no withdrawals or deposits, what will the loan balance be after 5 years? Ooh, my first mistake already in record time. What will the account balance be? Not loan balance. Write an expression for this and find the value. Pause it, give it a try. Answer time. So let's just say the balance equals $500, 2% each year. So it's 1.02 because it's 2% increase. And then it's the 5 years. So after 5 years. And then I've already got my Desmos calculator open. That's a lie. I have to open it now. But if I plug that in, I will get $552.04. So make sure you have that calculator open. These exponents don't give you nice numbers. It's just the way it is. So, after 5 years, she'll earn about $50 extra in her account. So, we're gonna talk about a lot of different percent increase problems and stuff like that today. So, Andy and Leah need to enlarge images for a group project. The two images are the same size. Andy makes a scaled copy of his image, increasing the lengths by 10%. It was a little too small, so he increases the lengths by 10% again. And Leah says, isn't that the same as increasing the lengths by 20%? So take a minute and think about if you think that is true or not. And as a hint, just give the image arbitrary length to begin with and see what happens. So pause it, give your best try. All right, so let's just say the image was 10 centimeters long. All right, so let's do 10 centimeters and increase it by 10%, so times 1.10. And then increase it by 1.10 again. How long is it gonna be? Well, 1.1 times 1.1 times 10 gets me 12.1 centimeters. All right, so that's Andy. He increased it by 10% twice. But then Leah, if I increased it by 20%, well, what would happen if we start out at 10 centimeters and just increased it by 20%? Well, that's times 1.20, because it's increasing by 20%. And that would just get her 12 exact centimeters. So, close, but not the same. And that's kind of the same as like if you go to a store and you have a 10% off coupon, but the whole store is 10% off anyway. That doesn't really mean you get 20% off. You get 10% off, and then you get 10% off the remaining price. So it's really something like 19% off. So just be mindful that it's not just adding. It's repeated multiplication gets us different numbers. Like having two 50% off coupons wouldn't give you a free item. You'd pay half, but then the coupon would give you half of half, so it'd really be a quarter. So, moving on, earning interest. A bank account has a monthly interest rate of 1% and initial balance of $1,000. Any earned interest is added to the account. So that's like pretty typical. You earn interest on your interest. So that's basically what we have been working with. You earn interest on your interest. So what's the account balance after 6 months, a year, 2 years, and 5 years? And let's see, it's a monthly interest rate of 1%. So let's see the balance after 6 months, 1 year, which is 12 months, 2 years is 24 months, and 5 years is 60 months. So let's just make sure we're doing our math properly. Pause it, do your own work, and then check with me. All right, so 1.01 is our growth factor, right? So it's 1,000 times 1.01 to the m power, if m is months. So we have to make sure that we are being consistent and using our exponents. And I'm using the Desmos calculator to really quickly do all this math live for you. So if I plug in 6, my answer is, after 6 months, I get 1,061.52. If I change that exponent of 6 months to an exponent of 12 months, I get 1,126.83. And if I change that exponent to 24, I get $1,269.73. And if I change my exponent to 60, I get $1,816, and that rounds up to 70 cents. Please make sure you're following along, doing the math yourself, actively participating. Otherwise, these are just random numbers that mean nothing. All right? So, write an equation. Well, we've kind of already done that here because I didn't read ahead. But the balance is A in terms of the number of months M. So the balance is $1,000, but I'm multiplying it by 1.01 to the M power. And assuming no deposits or withdrawals are made, that's like not super realistic, but sometimes if your parents set up accounts for you, like when you're a kid, sometimes they'll get like initial deposits of an account, and like you get better interest rates if you promise not to touch the money. So you'll get a better interest rate if you promise the bank, I'm not going to take money out of this account for 10 years, because then they can do more with the money. Basically, they can invest it in riskier accounts. So anyway, that's the realistic situation there. It's much more realistic than so-and-so has a credit card payment and they're not going to pay anything for a year. Like, that's unrealistic because you're going to go to jail. Okay, you good? Next page. How much will we're still on the same problem. How much interest will the account earn in 1 year? So how much interest will it get? Let's see. Back at 12 months, it had 1126.83. That's how much it had. But the interest was minus the original. That gets me $126.83 in interest. All right, see where that came from? Because I earned, that was what I had after 1 year, and that was my original balance. So the interest had to be $126. That's what the money that I made in that account. And what percentage is that? Well, 126.83 over 1,000 is, well, move that decimal point, 1, 2, 3. So it'd be 0.12683, which is 12.68% interest. So notice 1% a month isn't just 12% for the year. It's a little bit more than that because you're earning interest on your interest. So the term annual return, and you all want to learn about taxes in school, well, here's your first financial lesson. Annual return refers to the percent of interest an account holder could expect to receive in 1 year. So you can't discuss with a partner because they're probably far away. If you were the bank, would you advertise the account as having a 12% annual return? Well, let's think about it. You're the bank. You want people to have your account because that means they give you your money. So if you advertise as 12% return, is that accurate? It's close to accurate, Do you think the bank wants people to see a 12% return, or do you want them to think about a 12.68% annual return? They probably want people to think 12.68 because their customers are more likely to pick the 12.68% because it looks like customers get more money. Right? And in fact, you are. Because if you just say, oh, 1% a month actually gets you 12%, then you're not counting that last 0.68%. That'd be like saying you're going to get $1,200 after a year. $1,200 after a year instead of wait. No, I'm sorry. 12% interest would be saying you'd only have $1,120 after a year, whereas with 12.68% interest, you'd have $1,126. Because 12% for a year means after 1 year, you have $1,120 if you do that math, because that would be 1,000 times 1.12, and that's less than 1126.83. So the bank wants you to think you're getting more money, and in fact you are getting more money. So they really should advertise it as this. So it's really not 12% a year. It's really 12.68%. Credit card companies might say 12% per year, and in fact, they do that. So, over the years, so the bank account had an initial balance of $1,000 and earned 1% monthly interest. So each month, the interest was added to the account, and no other deposits or withdrawals were made. That's the previous problem right here. So to calculate the account balance after 3 years, Emma wrote this, because there's 12 months, it's the 36. And Talon wrote this. I haven't forgotten you all. You're all still in my head. Oh, dang it, another error. It's supposed to say Emma. So sorry. You're not Alina. And that's supposed to... I'm really bad at proofreading, clearly. I changed the name once, and I'm like, woohoo! So, think, why do Emma's expression and Talon's expression both represent the account balance correctly? And if you do the math, you'll find out that you get the same exact number. And in fact, that number you get is $1,430.77 it rounds to. And money always rounds up. I think so, at least. Well, in this case, it rounds up. So, why do they both represent the account balance correctly? Well, if you remember your properties of exponents, a power of a power gets multiplied. You multiply your exponents. You have a power of a power. Like 2 cubed to the second power. That's like saying you have 2 groups of 2 cubed. So it's really 2 cubed times 2 cubed. And okay, when we have this, it's really adding the exponents. But the reason for that is because this is really 2 times 2 times 2 times 2 times 2 times 2. So really, we've got 6 2's here. So there's that. So that's why it works, because power of power means we can multiply. And by expanding, we can see that. So what about what Jeffrey said? Well, that 0.1268 should actually look fairly familiar to us now. And where'd that come? There, that's where that came from, the previous problem. Because we earned that much interest. That was really our percentage yield. That was really the true annual interest rate. So will that work? Well, when in doubt, let's just put the dang thing in the calculator. All right, 1.12, what number is that? 68. And we got 1,430.67. So it's very close. And the reason it's not exact is because it's rounded. It's within 10 cents due to rounding. So yes, it should work. I'm going to say it works at least. If you say, no, it's off by 10 cents, like, whatever. Like, I understand that. But really, the true reason it works is because it's only wrong due to rounding. And banks would, well, yeah, banks would sort of understand that. So, a credit card company lists a nominal APR of 24%. So a nominal APR is like the approximate one. It's like, well, it's because it's 2% a month and 12 months a year gets 24%. So we just want to think about if they get 2% per month. And the nominal is really just the approximation. So you got to read that fine print on those dang credit card things. They'll say 24%, when in actuality, if you do 2% per month for 12 months, it's really not the same thing. And we'll figure that out down here. So $1,000 times 1.02 is now our new interest rate. 1.02. Let's see, 1 month to the first power is 1,020. Two months, 1,000 times 1.02 squared gets me, I'm running out of room here. I always start over to the right. It's a very bad idea. 1.02 squared gets me $1,040.4. I'll do the 6 months over here. And 12 months. It's a good thing you guys are all more organized than I am. So I do 1,000 times 1.02 to the 6th power, and 1,000 times 1.02 to the 12th power. And that 12th power is going to give us the true interest rate. So 6th power is 1126.16. And the 12th power, the 12 months, gives us 1268.24. And my general expression down here, 1,000 times 1.02 to the m power. And let's see, is it going to have us figure out the true interest rate here? Yeah, so next we're going to figure out what's called the effective APR. So it's really the true interest. So let's figure that out. So the new balance after 1 year divided by the original. So that new balance after 1 year was 1268.24 divided by 1,000. That gets us that's how much interest we accrued in the first year. And all right, let's go 1, 2, 3. 1.268. And if that's my growth factor, my interest percent is, you've all been lied to, interest percentage is 26.8%, not 24%. So this is how you're going to get lied to when you're an adult. Are you ready? They'll say 24% interest, when in fact, it's truly 26.8. All right? So, your expression here would be $1,000 times 1.268 to the t power, because that's how much you're really increasing each year without payment. All right. I think that's enough to be getting on with for today. So hopefully that went all right. I'll try to make your exit slip bearable for today. Let's see. I didn't do a password for today. Oh, geez. Whatever. Well, that's okay. You don't need one. Enjoy.